forget to record all this session. Let's turn off this thing. All right. Any question? Any question before we start? I hope you can see my screen also. Okay, let me type in all the information that are important to you. First, okay, it's a circuit theory one. Part one. And the next thing probably you want to know is the timetable. So let me touch a bit on the timetable side. Okay. So actually we are here today. We are here September 10 is our first tutorial one. Okay, you can see here, but it's a tutorial one. So we have until 11 a.m. Okay, so this is our first class. Our next session will be next week, and looks like it's the whole day session from the 8th in the morning until the 7th evening. So it's already a long stretch journey. So you have to be prepared, you know. But on and off, you can join us. Not necessarily that you have to join us all the time. You may go off for for toilet or something, for take a lunch or something. But most likely I will be here. Most likely I'll be here all the time next week, you know, to handle the lab session. And I also would record the session also. So if you are unable to attend, probably you have extra work to do. Probably you can come back to watch the video. But I remember last time I forgot to record the one of the session, probably due to the technical issue or something. That's why the safe bet is to attend it yourself on time, right? Online, not to wait for the video. Okay, they will be the safest way to do, based on my experience. All right, okay, this is the first thing. And our next session, T1 is today, right? Okay, 0909. Who is our lab session? 18. And to me, this sounds like a very important date, you know. So I would, because this during this time, these 10 hours, we will actually go through the question one by one, and I actually will show you step by step how to complete the lab, you know, and also show you how to prepare your lab report, the technical reports, because all your marks basically are all based on the content of your reports, not only the data you obtain from the experiment, but the all the content, including the introduction, conclusion, discussion. All those content are also crucial in the technical reports, and I have to make sure that you put all this in so that you can get the highest possible mark for you. Actually, I'll be there step by step as usual. I'll guide you step by step. I will not let you do it alone. You know, I will show you the how to get the result, and then you have to do it yourself. You have to capture your own screen. You know, when you draw the circuit, you need to capture it to as a proof that this is your work. And I'm going to show you all those steps. Okay, so at this moment, I will not look into the October's session. We just focus on September 1. Okay, we focus September 1. So this is the first thing you have to know. And the second thing that you have to know is the absolutely important is the resources for this class. First, you have to come to something we call the flex learning. We call the flex learn, short form flex learn. sometimes I remember as a flexi learn something. You know. Okay, flex learn. When you come here, because I already logged in this morning, that's why I don't need to go through the process again. And when you come in here, okay, you need to select the title that you want to go. For example, you come here, okay. So your focus should be on the menu is on the left hand side here, the left column. So the first thing probably you want to come is the course content, okay. And here you can see we have a total of 3 units, okay, 3 units. And when you click here, you go inside here, you can read all the information. There's some background noise. Let me see how to turn it off. There's some background noise there. I hope. Oh yeah, it's gone already. The background noise is gone already. Oh here, let me turn it off. All right. Okay, this is the. I remember in the past we have one PDF file. I wonder whether you can find it or not. You can find the PDF file which contain all the information here, so that you can read it offline. You don't need to come here online to read the thing. But I don't seem to find that right now. No, in the past we have the PDF file. Probably you can download here. But I think when you download, it's unit by unit, right? It's not going to be the full one. But it's okay. Probably there's a way they want me to, and because this is a latest structure where you will be the course material partially will be supplied by the online, some kind of online portal. You know, when you go to the another unit, let me show you. Let me show what I mean. When you go to another unit, they will show you some of the video, also online video on how to solve certain thing. Let me see, is it here or not? This is the notes. This is the part. I think this is a PowerPoint slide. Let me see this thing here. It looks like this time they changed already. Yeah, you can see the video here. Looks like most of the material are divided into the section. This is a PowerPoint. This is not what I mentioned just now. There's a PDF file. There's a PDF file contain all the material. But I cannot share with you because it's not really relevant to the circuit theory one. You know, this probably some of the content has been changed. You know, that's why I will not share with you. I worry that you read the wrong one. This is the one I'm talking about. No, this is not the one. Sorry. Let's find the one. Where is it? Let me see. Where is my PDF now? Let me see. B. It is the one. No. Let me look for another directory. Okay, let me see this. Send it to A. Oh, sometimes when you try to find, you just won't able to find it. You see, so many places I've been trying, but can't find here. Where is it? Let me see. Yeah, this is the one. This is what I'm talking about. The PDF file contain all the information, you know. But this I've been using for many years already. But the content is about the same. You see, it's a really convenient for you to read offline. It has a. It also included all the activities like the examples and the for you to some exercises for you to try, and with the answer also, with the answer behind it. Okay, where's the answer? Wait a minute. Remember, there will be they'll supply the solution. Yeah, I think this is a solution, right? This is a solution. Yeah. They also provide the solution at the end of the chapter, and you can go through it yourself. Yeah, this is all the solution. But nowadays, they change the way how they conduct the class. You know, they prefer to all go online. But I still prefer that they provide a PDF file, so that it's one place for you to get it all. Okay, so this is a place you have to come. Okay, I go too far. This is a place you have to come. Okay, and for your assignment, I think you have a totally of 3 assignments. One is the one going to be due early next month, assignment number 1. Let's call it A1. Okay, assignment number 1. How do you know the due date for this one? Okay, basically for what I'm doing here, usually I will, where is it? I will come here. It's called the by the way, this is the tutor portal, and probably the student portal will not look the same. Probably the layout will be about the same, but the content will be slightly different. You see the OAS stand for online assignment submission, right? So when you come here, for me, of course, I select your class here, Circuit Theory 1, and then you show me the list of all the students. Okay, let's check. Let's say I click one of the student here. Okay, so this down below here, at the title called submission details, I can locate the exact time and date for the first submission. Okay, so this one you have to keep in mind, because if you even though you can request for extension up to a maximum of 14 days, you can request our CC. You cannot make a request to me. You make a request to me, the maximum I can extend is 7 days, I think. I don't know whether I still have the privilege to I still have the authority to to grant you the extension or not. But if you request through the CC, you can extend up to for 14 days, I think. You see, extension request, resubmission. Resubmission, we seldom encounter this situation. Resubmission most likely is that you submitted a wrong file. This happened a few times. Sometimes you submitted the assignment for another subject, not the circuit theory one, and from another subject, for example, the accounting. You submitted to this circuit theory one. Then probably you have a request for resubmission. But this one happened, once a while. Every semester I had 1 or 2 students. They submitted the wrong subject assignment. Most likely, some of you have to go through the extension request. Okay, but for assignment 1, you can do this. Assignment 2, I don't think you can do that. This is their policy. Now, WOU policies stated that the assignment 2 cannot be extended. Only assignment 1. I don't know the reason behind it. To me, they seems like the same assignment, but they just don't allow you to extend the assignment 2. Assignment 3 would be your final exam, I presume, because for last semester, you will not have to come to a certain place to take your final exam. You just have to submit your final assignment. They take the assignment to replace the final exam. So you just need to complete the assignment, and then you will be all the way to graduation. Okay, so far I think you're clear about all these rules and policies. And one more thing I should point it out to you right now is the this, even though it's my email, but I seldom check this mailbox. And this lady, Oi Wen Hui is our CC, our course coordinator. CC stands for course coordinator. Probably sometime you can reach her. Probably if you make certain requests, let's for example you request for extension, but she's not able to attend to your request in time, and if you're in the hurry, you really want to get it processed fast, then you probably have to you can reach our CC, Miss Oi Wen Hui. Okay, you can reach her through the email. if he really didn't reply, usually she will reply within 1 or 2 days. If she didn't reply you in time, probably you can let me know. I will share her phone number with you. But because this is quite a private thing, right? It's a personal thing. It's a personal phone number. Really, I don't think I want to share it right here to everyone, unless it's absolutely necessary. Then I will do that. Okay. Let me see. Right now I've been talking about the next session will be lab. It's very important, and the resource, the place where you look for the information. Okay, probably I should touch something more about these resources here. Actually, the WOU, they actually want you to come here to ask question. Instead of ask question through the WhatsApp, which they cannot trace, they cannot trace the activity of the student, the interaction between the students and the tutor and the university. Actually, they all based on the evidence they can find here, the discussion. You can imagine a few months later or 1 year later, when they have an auditor come to check, to audit of all the subject here. They want to look for the evidence of the student and the university interaction. So there's appeal for you to come here and ask question here, instead of just asking a question through the email or the WhatsApp. In such a way that they can trace all the interaction, you see. But so far we have a little activity here, you see. We have 4 posts here. So do feel free to come here and post your question. I also try to post most of the information here, so that to make it useful. And otherwise, they're going to come back to me again and again and saying that they didn't see any student interaction. No, even though I can explain it mostly through the WhatsApp or email, but that is untraceable. You see, it's not easy to trace. So I hope you understand this part. Another one, the quizzes. I don't think you have a quizzes here. Let me see here. I don't think you have a quizzes here for the online one. I think this quizzes is for me, not for you, I think. Yeah. Last time we for certain class we have a quiz, online quiz they can take the quiz online. But I don't think for this class, you see. As far as I can remember, I don't think that you need to take any quizzes online here. So most likely you have to come to the content or discussion. For what I know right now. Okay. Yeah, another one is your course assessment. You can download it from here. Your first assignment. Your first assignment you can download it from the course assessment. Okay, let me put it down here. Okay. All right, I hope you can see all this. Let me change the bit. I don't think it's necessary. Let me save it first. Okay, let me save it here. So far, okay, everyone clear about this? The most important thing, of course, is the assignment. Okay. Due date. A1 due date. URL is the I remember it's the assignment. Correct me if I'm wrong. I think it's assignment.wou.edu.my. You have to come in here to submit your assignment. Let me see. Let me see whether this is valid or not. Okay, because I'm not a student, I seldom come to this assignment portal. Let me see whether this is valid or not. Yeah, this is the one, I think. This is the one. Okay, the most important URL for you in this class is submit your assignment, and the other one is to download the resources, and yeah, something to talk about the next assignment here. Okay, something to talk about the next assignment. You have to get yourself a PC. I don't know whether everyone has a PC or not at home, or any notebook or something. You need to have a PC or notebook, not an iPad or anything, not a handphone. You need to download. You need to download this Windows version. Download this they call the LT Spice. In your download and install in your PC. Okay. LT Spice. Let me show you what it looks like. It's a free software. You just download it, okay, and install in your PC. It's quite a small one. It's about, I think it's about less than 100 megabyte. It's somewhere less than 100 megabyte. Yeah, 30 megabyte, you see. 58 megabyte. 58 megabyte. But the installation process will take quite a while. Probably take you about 30 minutes to install all the files. That's why I strongly encourage you to do it before the start of the class. No, before the class begins, you download and install it. For the next session, okay, for the lab session, download it. The other one that we would use is the online software. It's called the for the lab. It's called the multisim.com. Okay. For this one, in preparation for your next lab session, probably you can, before the class begin, you come here and sign up to get yourself an account. It's free also, but the tools are limited, of course. So you just need to provide your name and your email, and then you put in a password, and then almost immediately you can use the account, so that it won't take too much time from you. Okay, LT Spice multi-sim for the assignment 1. I think it's assignment 1. Oh no, sorry, I made a mistake. Sorry, assignment 2. Assignment 2 is the lab plus a 1 or 2 question. Assignment 1 is right here. This is assignment 1, A1. We call it A1. This is assignment 1. It has 4 questions inside. If you scroll the way to the end, you can see question number 4. Each question, I think, carry equal 25 marks. Okay, I'm going to also help you to answer this question, but not really providing the answer to you, just to guide you how to get started for this question. So make sure you come back, you watch the video or you attend online session, and listen to the some of my tips on how to solve all these questions. I'm going to give you a tips. Otherwise, if you're ready to try all by yourself, I don't think you can get the highest. You see, probably sometimes you need some tips to help you get started. Okay, and don't forget to download this form also. Don't forget to download this so-called declaration form. It is a declaration for the plagiarism. Actually, it's the plagiarism declaration form. That means you are not this is your own work. This work is not copied from anyone else. This one is not copied from someone else. Okay, plagiarism. Did I spell wrongly or not? Let me see. I forgot to see. Let me see. Let me double check it. Where is it? Let me see. You see, every student when I mark, and by the way, I'm the one also mark your assignment. You see, let me pick one of the assignment in the past submitted by the student. You see, they attach this plagiarism here, PLAGIA. Okay, they spell wrongly. PLAGIA. All right. Strange, huh? How come this become a type error? Never mind. Okay. You need to fill up this form, with all your personal particulars. Your name, your student ID is the most important one, because I'm going to based on this one to match with your online student information, and then I'll key in your score. So if you didn't submit this one, probably the even though I have not see any negative consequences, any adverse effect of not submitting this form, but so far I think most of the students they do follow the rules and attach this declaration form to show that it's your own work, it's not copy, it's not it's not taking somebody else's work and then submit it, let your friend do all the work and then you just copy and then submit, because it's so easy to copy online. It's so easy to copy with a PC, right? You don't need to write down also. You just need to press copy and paste only. Okay, so make sure that you do that. Okay, submit your form, the declaration form. Okay, I think this is about all. I think we are about to start the class. Let me go through it one more time. First is the date and install software for the next session, for the lab session. The resources for the newcomers, the URL to look for all the resources. The contact details for our CC. Where to download the assignment, and the due date for the first assignment, and the submission URL. Incoming call. Hold on, let me see whether it's important now. Looks like it's going to be a call from the student. Yes, sir. Morning. Yes, sir. Dan speaking. Yeah, we have class. You need to follow the online URL. You sure? But we have a few students already right now. We have about 13 students here. We have 16 students here. Make sure you have the correct URL. Or you send me a message. You send me a WhatsApp message. I post you the link. Okay, thank you. All right, guys. Okay, there's a call from the student who couldn't find his way here. All right. Probably there are some information I missed. But I try to give you all the latest information. So far, okay. Anyone want to ask any question related to this assignment or the lab session, anything? Okay, you need to get a cell of PC for the next session. Cannot use a handphone. And also one more thing is that for the assignment, you have to type it in. You see, this is not a good idea. You see, this is a bad example. Let me show you the bad example here. You see, this student, he's submitting his assignment in the PDF file. You see, when you submit in the PDF file, it's hard for me to actually, to put my remarks, put my comments on the file. You see, what you should do is you have to submit in the PDF. Sorry, you have to submit in the Microsoft Words format, just like this student. So this is the way how we name our file. So let me show you. Okay, this is called the file naming convention. I think this one is policy again. Policy. You need to name it in such a way. This is the code, the class code. Let me show where's the class code. I think it should be this one, right? The class code. There's another one called the course code. But so far, I think there's a class code here. Yeah. Wait a minute. Let me double confirm. The other one is called the course code. The other one is here. TT1. I don't think this is the one. I think this is the one actually. CT113C. Okay. So you name your file CT113C, followed by your student ID. Give a space here, underscore, and then assignment 1 dot Microsoft Word. I'll show you the what I mean when I mark your assignment. You see here, I can easily add my comment here. You can see I mark your assignment here. I put your comment like this. You see, with this I can easily add a comment, whether it's correct or not, 5 marks, or I can say it's incorrect. Your answer is incorrect. I can easily add my comment here. If you submit in the Microsoft Word file. So if you submit in the PDF file, which is not allowed, but sometimes it leaves me no way to find another way to mark it. It's not the way we like it. It's against the school policy actually. If you read carefully here, the school actually has the right to reject your assignment if you are not adhere to all this the instruction here. You see, submit your assignment to this AOS. This one we know. And you said you cannot use a handwritten assignment. You have to, even though you take a photo, Photoshop, it's also not accepted. Will not be accepted. You see, not your handwritten assignment. And you have to use Microsoft Word and the Times New Roman 12-point font. Okay, hold on. Let me post the link to this student because he couldn't find a way here. Let me post the link. I think he's waiting outside the classroom. Let me attend to this request. Hold on, let me see. Where can I find the link here? Wait. Usually I can find here. Never mind. Just let me go out here. Let me go out from here. Copy. I can copy from here and get the link to the channel. Let me start. Oh, the wrong one. Wait. All right. Let's continue. This happened usually in the first tutorial. So far, okay. You've been very quiet. I'm sure that let me put in the detail here also. With MS Word, okay. The assignment need to be do it with MS Word software, not the PDF file. All right. Of course, we won't jump into the assignment right now. You see, I think everyone's still very fresh right now. I don't think we're going to go ahead and discuss about this. Is pointless, right? It's not making sense to discuss how to solve all this question right now. Let's go through. You see, now it's about Line 35. You see, we still have plenty of time. Let's go through the slide until let's say 10. Then we take a break. We take a short break, and when we come back, probably we can look at one of the question here. All right. How does it sound? Let's start the class right now. For the first unit, we call the T1, the tutorial 1. What you're going to see is all the basic in the circuit theory, all the basic stuff. Okay, it's not so heavy. Tutorial 2 is a bit heavy because you need to learn about some of the technique or theorem, some of the methods, how to analyze the circuit. When it comes to circuit analysis, it's always not easy things to do actually. Just like a math, you need to go through the calculation, analysis, and then by solve all the unknown. Sometimes it's quite burning a few brain cells. Okay, let's get started right now. Let's move on. So what you see here is talking about the unit. I will not go in detail. Some of the unit I think you are really familiar with is the meter, kilogram, second, ampere. Probably this class you learn about the ampere. Kelvin is for the temperature, and these two most likely for the used for the physics, not really used in the circuit. Okay, and then some other useful units. We have the also the formula. Also, they call the formula. But to me, I call the unit. This is called the unit. This is a unit name. This is a unit. So we have an ohm to measure the resistance, the voltage, to measure the volt. So another formula is the joule divided by the coulomb. Okay, the coulomb actually is the ampere times the second is a coulomb. Joule is the okay, it is correct, huh? Newton meter. Never mind. Okay, so you don't need to actually try to memorize everything here. You just show you some of the unit used frequently in this circuit. Okay, some of this you may see all these unit in the later chapter, not right now. Okay. Then when we come to the SI unit, I think the first thing you can see here is a giga, right? Giga, mega is the one what we're familiar, or tera, because we use hard disk a lot. Now it's come to the terabyte, right? So everyone know T, everyone know G, right? Even though for the non-engineering student, they also know the mega, giga, right? Okay, these are all the unit from the smallest all the way to the largest one. Exa is 10 to the power of 18 0. Okay, so just something to let you know. Don't need to remember. Once again, you don't need to memorize everything here. They will not have the question like this in the exam or in the assignment. Okay, what you really need to know is some of the theory behind all this circuit. So this slide or this topic is talk about the relationship with the charge and the currents. The current is a measurement of all the charge flowing through a conductor. This is quite useful here. This number, 1.602 times the 10 to the power negative 19 charge. You see that one charge, negative charge or positive charge. Positive charge we call the proton, right? We call the proton. Okay, the electron can be a positive or negative charge, right? Positive or negative. It carry a magnitude of 1.02 times 10 to the power of negative 19. It is a coulomb or not? I forgot already. I think this is still charge. Oh, it's column. So it's a column here. There's a column here. Column. So 1 ampere. 1 ampere is how do they define the ampere? So far we know that from the physics point of view, one charge. Let me get my pen here. Okay, you can imagine something like this here. This object here is a conductor. So when you supply the conductor with an external power source, this one will create a current flow in the conductor. Okay, so we must come up with a way how to measure the total charge flowing through the conductor. Is by using all this unit here, 10 to the power of 6, this number. This only for one charge, you see, only for one charge. For one charge, positive or negative, it can be a positive or can be a negative. You only carry, this is a very small amount, you see. One charge carry very small amount of the, we call the charge, measuring in coulomb. Okay, this is how we define, how we see all these charge and the currents in the circuit. You can say that in simple terms, you can say that the current is a flow of positive or negative charge, in the circuit. So the current flow. But I like to actually associate this one with another analogy, the water flow analogy. You imagine that this is a water pipe, and the amount of the water can flow in through a pipe within certain time. Let's say within 1 second. How much water can flow through the pipe is defined as a current actually. But in the daily term, when we measure the total amounts of water flowing in the pipe, we just mentioned is how much water flow through the pipe, how many liter per second or per meter. This is how they measure, right? How they measure the power of the water pump is the work done. For example, 18 liter per minute or per 10 seconds or something. Okay, all these are actually currents. When it comes to circuit, we call the currents. And the voltage here is the one pushing the charge across the conductor. So the voltage is some kind of a potential energy to push some kind of pressure. You can see when you relate to the water pipe analogy, the voltage can be viewed as the water pressure in the water pipe. You see, so the water pressure is the one to push the water forward, allow the water to flow through the pipe from the lower ground to a higher ground. We need a water pressure in the pipe, right? So the water pressure is a voltage here. Is a voltage, and then we have a current, and then the other property we have is called the resistance. We'll touch the one later on. Okay, but so far you already exposed to this water analogy, means the voltage, current. Let me start this one with another application. I think it will make my job easier. Let me start this one with another, so I can write something on the slide. You see, I want to write something on the slide. Let me start on the where is it? I think this is the one. With the mouse of H, so that I can write something here. Okay, where were we just now? We were here. So let's imagine you have a water pipe. Okay, let's imagine you have a water pipe. Okay, with all the water flowing inside. Okay, the current actually is equal to the flow rate of the water. Okay, it's the flow rate of the water, and then the voltage actually defined as a 2 point, the potential difference between the 2 point. Let's call it a point A and point B. So the voltage between 2 point, VAB, for example, the certain voltage, right? X volt, right? Volt is a unit. So this amount of voltage is actually the water pressure. You can imagine this one. It almost like the when you imagine when you take the water flow analogy, it almost like the water pressure. Water pressure. Okay, you need a water pump to increase the water pressure, of course, right? So the water pump would be something like the charger. Okay, something like the power supply. So the voltage actually can be viewed as the water pressure in the pipe. And then how about the other one? The other property is called the resistance. Over time, you can imagine your water pipe become filled up with all the dirt or debris or the gunk. They call the gunk. See, all the dirty particle inside the water pipe. This one will slow down the water flow, just like our blood vessel. When we have the high pressure, means the blood is difficult to flow in our arteries. Okay, so this is viewed as the resistance. Resistance in the circuit, you know. But when it comes to the water flow, it can be the dirt. The dirt built up inside the pipe will have some kind of effect or the resistance effect to slow down the flow rate. That's why we have these three properties: V, voltage, current, and resistance. Okay, but I'll prefer it to view it this way. You just put the V on the top, you put the I here, R here. Okay, then you draw a divider between them. And then from here, you can easily obtain the Ohm's law. This we call the Ohm's law. Later on, you can see this. Ohm's law, where define V equal to IR. V is equal to I multiplied by the R. I is equal to V over R. And the last one, R is defined as a V over I. So if you can memorize this this formula here, this pattern VIR, you can easily obtain the Ohm's law by just looking at this. If you can visualize this one in your head, I think it won't be difficult for you to to remember this equation. Hold on, let me see. There's another message coming in. Let me attend to the question. Hold on, a few seconds more. Sometimes because some students probably they use a different PC, probably their PC installed with the some problem software. Okay, you see with me? All right, so we have understand the basic properties of the electric circuits, which is the voltage, current, resistance. And when it comes to the physics, if you want to express this one mathematically, you want to express everything you see mathematically in the circuit. First, you have to start from the current. So you can see here is the current is given as the change of all the charge over time. You can view it something like the change of all the charge within certain time. Within certain time, let's say you say so much charge, okay, so much charge within 1 second, so much charge across this point A. If you have certain amount of charge flowing through point A within 1 second, this is defined as the current. Okay, If you want to find out the real definition, of course, you can always go to the Wikipedia. I think Wikipedia provide the definition of 1 ampere. Definition of 1 ampere. 1 ampere is equal to, let me see, where I can't see here, the definition of 1 ampere. People always say, pronounce it as 1 amp. Okay, so 1 ampere carries a total charge of 6.24 times 10 to the power of 18 charge carriers, moving across a certain point in 1 second. So this is the definition of 1 ampere. When you buy some device, you say that this device can supply 1 ampere. Let's say your battery charger. So it means you can supply within 1 second. There will be 6.24 times 10 to the power of 18. This is a positive, right? 18 charge per second. In 1 second, there will be so much charge flowing through certain point, you see. But if you recall, in one charge, we only have 1.6 times 10 to the negative 19 charge only. In one negative or positive charge, okay, we call the proton and the neuron, right? So we have one charge only has 1.6 to the 10 to the power of 19 charge. Column, sorry, column. Charge is C is a column. But you see 1 ampere, you have so much coulomb per second. You see 6.24 times 10 to the 18 coulomb per second. So you can imagine within 1 second, so much charge flowing through the certain point in 1 second. You can do the math. How much charge flowing through a certain point in a wire in 1 second? If we say that the flow rate of the current is 1 ampere, the magnitude is 1 ampere. Of course, we can play around with this one. You see the original form is I is equal to dq dt. If you are the physician, if you are good in physics, you need to memorize this one. So if we take the dt over here, so the dq become I dt. So we throw this one, the differential, to the other side, so it becomes integration. So q become integral of I dt from t equal to 0 to t to t. Okay, from t equal to 0 to t. Okay, this is how they define the charge. You can calculate the total amount of charge by playing with this formula. You can throw this one to the other side and bring this one here, and then you can calculate the total amount of charge flowing through a circuit by given a certain current over a certain time. Okay, here is another example. It said that in some circuit we have a total charge of 2005 protons. So it's a proton or electron. You see the proton or electrons, protons for positive, electrons for negative. So the 250 proton, so we understand that one charge can only carry this amount of coulomb, one charge. One charge particle can carry total amount of 1.602. It's a very small number of coulomb, you see. So if you have so many charge, what is the total charge carried by this proton? So we just multiply by 2005. You see, it's straightforward. Okay, it can be the charge. Remember, the charge can be positive or negative. Positive is a proton, negative is an electron. Okay, sometimes they will achieve the equilibrium, like a battery. When you have like a battery, initially we have a, let's say T is a positive and negative, right? Initially at the negative side, we have excessive amount of electron, electron at this side. Let's say we use E, and then when we charge the battery, actually we push all the electron to one side, all the proton to the other side, and they are so packed in this area. When you connect a circuit, full circuit, allow them to flow. So the from the physics point of view, the electron will start from the negative, go to the positive to achieve the equilibrium. Because we have high pressure here. Here's a less pressure. So electron most likely to be attracted by the proton to the other side, and to combine with the proton to be neutralized. So when you have to imagine when this electron is flowing from this terminal all the way to the positive terminal, actually they will be neutralized. We call it neutralized. Neutralized become a no charge at all. It will be neutralized. So the process of charging a battery is really is a pumping a lot of electron, negative to this side, and then positive to the other side. So so that we can, when you connect a circuit, the pressure will help to push all these electron from this terminal to the other terminal. Okay, so this is how we understand the circuit flow. All right, this is another example here. See whether you can understand or not. So this in this question, we are given an equation, total charge. So Q is a total charge. It's given by this formula, phi t sine 4 pi something, right? Milli coulomb. So it wants you to calculate the total currents ampere at t equal to 0.5. So this means sounds like we have, okay, sounds like we have a Q given a certain column here, but with the time as the another parameter. Time is another parameter. If you substitute the time here, you can calculate the total charge. Okay, if you substitute the time here, so this looks like a sine function to me. It looks like a sine function, right? It's a sine function. So the time, let's say the time is 0.5. If you put in the 0.5 here, you can calculate the total charge. Entering a terminal. This is the total amount of charge entering a terminal. So it's to calculate the current, you need to bring out this equation. The current is defined by the differential of dq, change of charge over change of time. So the change of time is 0.5. But the first thing we need to do, of course, to find the dq dt. This is a q only. So we want to do the differential of this equation. The first step is to take the differential of this equation, dq dt. We done this one in the school, right? But if you still not so sure, you forget about all this differential. There's one place can help you out. You can come to the website like Symbolab here. You come to the derivative, another name for differentiation. You just type in this phi t sine. Let me try this one out. Sine 4 or pi t. Sorry. Don't be confused by the t. The t is defined as a time, right? For here the dx d something dx, right? So here you you have to replace the t with the x, because these are d something d over dx. This is d over dt, right? So we have to replace it with dt and see whether this website can help us to solve for the answer or not. Okay, I think this is not what we want to do. Let me try. Let's try to put the 5x here. 5x. Actually, it should give us some answer here. What we expect is here. 5 sine. See anything? I make a mistake out here. Probably I have to put here inside. Wait. Probably I need to put everything inside the bracket. Let me try this. I remember last time this can work with no issue at all. Let me see. Yeah, this answer, right? You see, 5 sine 4 pi plus 4 pi x cosine. So this is a function we get. You see, so for the today's student, I don't think you need to. It's good for you to able to do the differential, the derivative yourself or the differentiation yourself. But today's we have so many tools around us to help us to do this, you know. So so it's up to you. Many experts still believe that if you can do it all by yourself manually, it's good for you. But just to propose some of the alternative way where you can calculate the result, you can do the differential with online tools like this. Okay, so if you can come up this one, the differentiation, and then you just need to substitute the t with 0.5. T is given by 0.5, right? So you put the substitute the t inside here. So 0.5 times 4 become 2. 0.5 times 20 become 10, and so on. Okay. So eventually, if you simplify the whole thing here, you come up to 31.4 milliampere. Okay, this is how we solve the question like this. Initially, we have the quantity given by the total the charge. Need to calculate the total amount of current at 0.5 second. Okay. So imagine that you have this conductor here. We have charge with so much column flowing through the point A. Okay, so this is a time scale, our time. At 0.5, we always assume start from 0, right? At 0.5, there has been so much charge flowing through point A already, right? So much charge flowing through point A. We want to know how much charge in the unit of ampere, how much charge flowing through point A after 0.5 seconds. So this is the answer. In the unit, ampere unit, so much charge flowing through certain point in a wire at certain time, you know, we have so much current flowing through. I think you can try to associate this one with any battery charger. When a battery charger say it can deliver 3 ampere charging a current, right? So you can imagine how much charge flowing through the wire, let's say within 1 second or 0.5 seconds. Okay, you can try to associate this one to, you know. Okay, let's okay, let's go through a bit more until we end this slide. All right, and here we have to talk about the voltage. So the voltage is always the potential difference between 2 points. When you view the voltage property, you always need to associate with 2 points. For example, point A and point B. So the difference here, we call the voltage difference. Actually, it's called the VAB. So on at one node here, we call the node, usually we have the same voltage. For example, let's say you have a circuit like this. Circuit like this, right? And probably another branch like this. So this node and this node and this node, they are the same actually, because they have no component, no element between them. So these three nodes as viewed as the same node VA. So if you really want to measure the voltage across this, we use the term across, the voltage across this resistance A. You really need to know the voltage here, so that we can define the voltage of the component A. Component RA actually is the VB minus VA. We assume the VB is higher than the VA, so we'll get a positive value. Okay, so this defined as a voltage across. Sometimes we use the word as the voltage across certain thing here, or we say that the voltage drop across certain thing. For example, you have the a voltage of 5 volt. Okay, so initially it go through at one component, and then you go to another component. You see, when you go to the component, this establish the voltage difference between this point and this point. If define this point as A, or this point is B, so the voltage across this component is a VAB. Right? Usually we write in this way, VAB. The voltage across this point and this point. And then if across another component here, so this component here should have another potential difference, C. So this voltage here and the voltage here should be different, because they have something here in between, which drop the potential, the pressure, the water. When it comes to the water pipe analogy, is pressure, right? So the voltage always has the taken from 2 points, A and B. Okay. So the voltage is defined as the change of work over the change of the charge. So the W here is the energy. Change of energy between these 2 points over change of the charge. So it looks like you measure the total amount of work. Total amount of energy done by this certain amount of charge across 2 points is measured the voltage. It's a bit hard to understand actually. You really need to get more information in order to fully appreciate this equation. What is the differential of voltage? Even though we understand voltage is a certain kind of pressure in the circuit between 2 points. So at a single point, the pressure should be the same, but at 2 points, the pressure should be different. Provided that in between, we might have some kind of component here. We might have some component here to drop the water pressure from here to here. So the voltage is defined as a change of the work energy over the change of the charge. Okay, so these are it will require you some time to fully understand the theory behind this equation. Why is defined as a change of the work energy over the change of the charge? Okay, probably later on you can search online to find more information, to explain this scenario. And the last thing we're going to talk about in the first session here is the last one, called the power. So the power is measure of the change of the work done. Or sorry, I always look at the W as a work. Actually, here is energy, but work also can is similar also, the work done or the energy. But it's better to view it as energy, I think. So the power actually is the change of the energy over the certain time. You see, over per second or per 2 seconds. Okay, within this 2 seconds, how much work done is considered the power. So it's always confusing for for us, you know, even for me sometimes to confuse with this word energy and the power. Sometimes we think they are similar. When we say this thing has certain power or certain energy, we always try to think that they are similar. Actually, they are different. Actually, they are not the same. Usually, they sound like the same. Energy sounds like some kind of power, right? Let's say this engine can produce so much power, can produce so much energy, but when it comes to the physics, they are different properties actually. The energy, the work done, okay, is defined as a total of energy, change of total amount of energy over total amount the over certain period of time, dt. Okay, so this is the voltage across the element is the current flow through the element. P is the power in watt. So the unit here is a watt. The unit for the power is watt. And the unit for energy is what? Is joule. Okay, so this one is the unit for this one is the joule. You know, sometimes the battery also can use the joule to represent the battery power over the change of period of time. When you go to the online, sometimes you see when you buy a battery, let's say your battery can deliver 2000 ampere milliampere, right, hour, right? You can always convert to joule. I think we'll convert to joules again, right? You can see there are certain calculator, online calculator to help you convert from the ampere hour, to the joule, to the also can convert to watt hour, to how many joule energy. So charge is measured in ampere, energy measured in the watt, energy also can measure in the joule. This one we want to look at calorie. Calorie is more like the food, you know, the energy inside the food, measure measure the, you know, associated with the food. So we always use these two only, you know, or these three, AH, kWh, or joule. But usually people would use only AH or kWh. Right? People seldom use the joule. But when you come to this class, most likely sometimes you will use the ampere to represent certain property, the current. I don't think you'll use the coulomb per second, right? Even though the ampere is equal to coulomb per second, but when we come to our daily use, we prefer to use ampere rather than the coulomb per second. This is what I mean. Same for the joule. So looks like the joule is not really frequently used unit. You know, people like to use watt hour, ampere hour instead of the joule. But when come to the theory part is quite confusing. You see, the theory part. This is the joule per second. This is a measured in second, joule per second power. Okay, so we can also play around with this term here. We can break apart. We can put the dq. We can put the dq on the top, and then the dt at the denominator. The numerator we can put the dq. Denominator we put the dt. And then in between here we can use a buffer like the dq here, so that they can cancel out, right? They can cancel out. But if you look at this one is actually, this term here is actually voltage, change or amount of work over change or amount of charge. And this term here we see in the beginning, change or amount of charge over charge is current. So the power actually can be defined as a voltage times current. You see, this what most of the engineer they just memorize this one. They always memorize the power is equal to voltage times current, right? Okay, this is where it come from. This is where this equation come from. You need to start all the way from the dq dt, and then all the way through the voltage, then all the way through the here, and the final you arrive at the total power can be written as V times I. Okay, this is uh, how they use these two terms, right? Okay, guys, we're going to take a break right now. I need to take some water. We'll come back in a short while. Let me make sure the recorder is still on. Yeah, it's still on. All right. Let's take a short break right now. All right, I'm back. Let me see whether you can answer some question at this stage. Let's look at the assignment. Okay, let's look at the first question here. This will be the following question. Let's look at this one. So you see that I think I need to open this up with the with the Microsoft Edge. I think that would be better. Let me see. Where is it? I think this is the one. Yeah, October 9. Okay. See, with the knowledge we acquired just now, see whether we can solve this question or not. So if they say that the voltage difference across a device is given as this one, this function, 4 exponential to the power of negative 3t, some volt here, some you need to put in the t to calculate the total voltage at a certain time, and the current is given as the -2 dv dt. This take this voltage, put in here, and take the derivative, then you can calculate the current. Okay, looks like we have two functions here, one for the voltage, one for the current. So the current looks like current is dependence. Current is depend on this voltage. So first, actually, we also given the function to help you to visualize. You can figure this function out by looking at this function. So is the voltage is slowly dropping across the time. When the time increase, the voltage will drop. Eventually, probably drop to 0. Okay, the first is to find the part 1 is to find the current through the device. So apparently current this is the current. So it looks like the current we just need to take negative 2 multiplied by this part. See, so the current here looks like the current. The current is taking the negative 2, which is the constant value, multiplied by this value. I will call it x right now. Then we can calculate the total amount of ampere. Okay, and the dv dt is not given, right? But we're given the v. That means we need to take the derivative of the v voltage as a function of time. So what you need to do is you can use you can do it yourself. Do the derivative of this voltage, okay, and then you get so you get the answer something like the something, okay. Let's see. There's no unit here. You see. So you after you've done this, you'll get the x. Okay. Let me give you a tips. X is something like the let's see. The x is something like some number. We still preserve the exponential. Some number here, exponential minus. Wait a minute. Does it make sense? Oh, no. Sorry. Yes, it's correct. It's correct. Minus 3t. The 3t is still there. Okay, the 3t is still there, but the 4 will change. Okay, the 4 will change. Yeah, the 3t is still there. Yeah, the 4 will change. Okay, so you just need to figure out what number this is. Then you can calculate the first current. All right, for the part 2, to find the total charge delivered to the device from t equal to 0 to t equal to 1 second. So this one can be defined as the total charge. So the total charge Q delivered to the device is equal to, when you see the total charge, from certain time to certain time, most likely is the integration, from time from 0 until 1 second. So the the formula for the total charge is the current, right? It's the I dt, right? So I is the one you obtain here. So the I is the one you obtain from the part 1. So you just need to put this one in. Okay, all you need to do is to put this answer here, where you obtain from part 1. You put in here, and then you do the integration from 0 to 1, and then you will get the answer something like less than 10 coulomb. The unit is coulomb. Okay, this is the answer. And this is the answer for part 1. The something E minus 3t ampere. Answer for part 2 here is less than 10 coulomb. If you can calculate something less than 10, most likely you are correct. If you calculate something like more than 10 coulomb, probably you are wrong somewhere. Okay. And the last part is to find the power absorbed by the device. So just now we were struggling to differentiate between the power and energy. So this power is referred to the voltage time current, right? So we are quite sure, because the energy, the voltage is the change of the energy, or change of the work over the change of the T, right? It's really hard to understand, really. Change of the work over the change of the T. Okay, but the power, we understand the power is actually V times I, right? Sorry. The better way to write this thing here, I think I think the correct way to write this one is like this: the power in the function of as a function of time is equal to the current as a function of time from here, current as a function of time, multiplied by the voltage as a function of time. So of course the voltage is here. You don't need to do anything. You just need to take this one in, and then you just need to take the IT from part 1, and then you take the VT from here, and then if you multiply these two, your answer will be something, okay, some unknown E to the something is no longer 3, of course, T, and then unit is 1. So I leave you to find out, okay? I leave you to find out what is the number here and what is the number here. Number E to the exponential to the power of something T. Definitely it's not 3T, you see, because you multiply these two. Okay, if you are not so good at this mathematical formula, you can always come to the website like this to help you do the calculation. So no worry at all, actually. Okay, let's continue so that we can solve the part B. Let's continue further on our slide. Yeah, right now we are talking about the dependent or independent source. Excuse me. So we have an independent source, independent current, and independent source, voltage source. That means independent means they are not really related to each other, right? It's called independent. They have no other any link or any anything that will relate to each other. We call it independent. Independent current usually is given as a V or I. I, you can see the symbol. You need to really observe the symbol here. I will use the arrow as a symbol, as a current flow. Okay, the current flow. Okay, the voltage is the something like the positive and negative terminal. We have positive and terminal between 2 points, right? So when we call when we call independent, so they are given as most likely is a V, V or I. So as opposed to the opposite one, we call the dependent. If something called a dependent, most likely is in the form of V equal to 3I. For example, okay, for example. Dependence, that means this voltage is depend on this current. You just take the current, you multiply by 3, and then you will get the voltage. So this is called the dependent, right? Voltage is depend on the current. Or voltage is 3 times the current, so it's called a dependent. But independent means they're nothing to do with each other. Let's say this is 3 volt. Let's say this is 1 ampere. They have nothing to do with each other. They just stand alone, isolated, stand alone. Okay, then we have dependent source, and we have come to the first possible combination. We have the voltage, we have the current. The first combination is the voltage control voltage source. Sorry. How do I present this one? I think I have to present it with the cube form. This is the first time I try to do it this way. This is the first time I try to do it this way. Something kind of suddenly come to my mind. It's possible to explain it using this way. So we have a voltage and I, and then we have the what's the C? Control. This is a source. C is a control, and S is a source. Something controls something, right? Or the source coming from where it's coming from. So the first one is the voltage control, voltage source, voltage control. Voltage control, where is it? VC and VS. Yeah, VC, VS. Voltage control, voltage source. Voltage control, voltage source. The first one. So what it means is that you have this voltage here. You have this voltage. Like what I say, the voltage is always defined as the potential between 2 points, right? So the voltage at this node is a 15 volt. The voltage at this node is a 10 volt. So the voltage between A and B, we call the voltage difference between A and B, is given as, we always take the largest one minus the lowest one, because the voltage drop, right? It dropped from the 15 volt drop to 10. So the VAB is 5 volt, right? The difference between here is a 5 volt. So this is the voltage dependent voltage source, actually. Voltage control voltage source. So this voltage control voltage source is given a shape like a diamond shape. It's a 3 VAB. So you just need to take the 3, multiply the VAB. VAB we found out to be 5 volt. So the potential here is equal to 15 volt. So what it means is this voltage source, this is a source, it controls the voltage here. Okay, there's a voltage here controlled by these two voltage node. So you also can say that this voltage source controlled by this voltage VAB. So you just need to multiply 3 times, for example, 3 times the voltage here, then you can get the voltage source here. So this is defined as the voltage control voltage source, the first possible combination. Okay, the second one is the current control voltage source. Okay, so let's say you have a current flowing through this device. It's given as 2.5, and here is a current source. This is a source. Okay, this one is the source, one is the control by, right? This control by this one. This is a C. Controlled by 2.5. So this one, if you calculate, is the 2 times I1. I1 is 2.5, so it becomes 5 ampere. Sorry. This is very confusing if you are not careful. You always can make mistake. You see. So the way confuse us, because we see the I, we always think the answer must be ampere, right? But it's wrong actually. Okay, this is the way you need the place where you need to pay extra attention. When you're dealing with something like this, some kind of funny shape like the diamond, even though the unit here is one of the parameters is I, but the answer is not in the ampere. If the answer should be based on the terminal here, because current don't have a terminal, right? Current is a direction of current flow. Current is a direction. But the voltage is the potential difference between two nodes. So this is the voltage source actually. This is a voltage source, and this is a current controlled by this current. Okay, so this one the answer should be 2 times I1. So we can be viewed as a 2 times 2.5. Since this one is a voltage source, positive, negative terminal, so the answer should be in volt, in unit volt. Okay, so this is called a current control voltage source. Okay, so what you see here, let me give you more in-depth information. What you see here is we call the equivalent circuit. We call it the equivalent circuit because it helps us to analyze the actual practical circuit. The actual practical circuit can be coming from here. For example, you have one transistor. Probably you'll learn this one later on. You have one transistor like this. This is the symbol for transistor. Transistor is the electronic switch. Okay. Here, your transistor like this. So let's say you supply certain current here. For example, your current is 1 ampere, 1 amp. And then there's a voltage here. You try to measure the voltage for this RA. Okay, so the voltage is measured across the RA from this point to this point. And this is an example of the current control voltage source. Based on this transistor circuit, most likely we look at the beta. You'll learn this later. So the beta actually always defined as the current multiplied by the beta. You see, to amplify, this is an amplifier, right? To amplify the current. So the current supply, this is a source, okay? This is a source or the control. The current control this switch, and this switch turn on, and this voltage source here, we call the VRA. The voltage source here, VRA, is take the current multiplied by this constant number. For example, let's say this constant number is 550. So the voltage here will be 50 volt. So this is the actual practical circuit. This is we convert this circuit to something like this in the circuit form to help us analyze the circuit. So sometimes we can convert it to something like this. So the current flowing through this branch will determine the voltage here, will determine the voltage at the output side. So if you view this one as an input of the circuit, if you view this one as an output of the circuit, so the input will change the output. See, so in the circuit, we can convert the circuit like this sometime to something similar to this, where the current flowing through this component. So this component is here. Current flowing this component will decide on the total output voltage on the other side of the circuit. You can see what you can see the point or not. The current flowing to this device will determine the total output voltage on other device, on other part of the circuit. Okay, so this is how they define as a current control voltage source. Okay, we also have another possible combination called a voltage control current source. When the voltage here will control the current source on the other side of the circuit, and this one you can view as the in the practical circuit is an op-amp. In the practical circuit is the op-amp circuit. Let me quickly go through this one, not to take too much time. You see the for the op-amp circuit, this side is the input. Okay, this side we can actually supply the voltage. We can supply the voltage V in here. Here's the ground. Okay, here's the ground. And then on the output side here, on the output side, we can take one resistor here, and this is our V out. So the current here, the current flow through this R, let's call this RB, this RA, this RC. The voltage you supply here will determine the current here, you see. For example, the current is equal to 5 VI. Okay, for example, okay, for example, wait. Let me give you a more logical example. Phi negative phi time RA over RC time VI. You see, this current flowing through the output, this output side, is depend on the voltage at the input side over this some kind of ratio. Okay, so let's say you supply 5 volt here, and let's say this is a 1K, this is the 10K. So the output would be, the output current here would be 5 multiplied by the RA 1K. It's a ratio of 1 to 10 times the VI. This is you supply 5 watt, right? 5 watt. So you can calculate 5 times 5, 25, and then 1 over so 2.5, right? 2.5 and 2. This in the real world circuit, we have a circuit like this. Sometimes the output current is depend on this input voltage. That's what it means. Voltage control the current source. So this current source is controlled by this voltage. So when you come to the circuit analysis, people don't like to draw it this way. People like to convert this circuit into something equivalent circuit like this. So we can see more clearly. There's one current source here indicated by the arrow. So this is a current source. This current source in the unit of ampere is controlled by this voltage. This voltage is somewhere in the circuit, somewhere else in the circuit, from C to D. We call the VDC. So you take the 3 volt minus 7 volt is a negative 3 minus 7 is a negative 4. So the answer for this current source will be minus 20 ampere. 3 minus 7 multiplied by the 5. We call the amplification ratio, right? amplified by 5 times, amplify the voltage 5 times, but the output is a current in current. That's why we call this one. We call this one as a voltage control current source. So this one is called a voltage control current source. It's a current source, but it's controlled by the voltage. Voltage control. The voltage is coming from here. This voltage control this current. Okay. The last one is the the last one is what? The last one is we almost run out of time. We need to move a bit faster. The last one is a current control current source. So this current, this is the current source controlled by this current by 2. Not this current. This current source is controlled by this current at another branch. Okay, this branch and this branch, they are different. Okay, this one is called the current control current source. Okay, current control current source. This is the one control the source here. This is the source. This is the one that control it. The one control the source. You see, it's a bit confusing, right? One is the source. One is the one that control the source. Okay. Right, we need to move a bit faster. Now we come to the resistance. So this formula is extract from the physics. The total resistance has to depends on the material you use. Another parameter is the length of the wire, and the other parameter, the design on the resistance, is the area, the sectional area, the cross sectional area. With given any wire with a certain diameter and certain material like the copper, like the silver or zinc or anything, right? Every material, they have their own resistivity. We call the resistivity factor. Okay, so this one multiplied by these 2 parameters, you will come to the total resistance. So this is from the physics. And for the resistance, I don't think you need to learn how to read this one. Okay, if you want, you can always refer to the online resources. There are many people show you how to read this one. Okay, and here is quite an important slide actually. Here give you an idea of which one is a node, which one is a branch, which one is called a loop. Okay, how many nodes we have here? How many branches we have here? So this is called the voltage node. Between here and here, this will be a voltage different. Between this node and this node will be a voltage different. Between here and here should be a voltage different. So we have the 1, 2, 3, 4, 5. These are the same as well. There's nothing here. This is just a wire. So this is one node here. 1, 2, 3, 4, 5, 6. Okay. Wait. Sorry. These 2 are the same. So this is a wire. There's a wire here. So this consider only one node. 1, 2, 3, 4, 5. So total of 5 nodes. When come to the branches, this is called the branches. This is called the branches. This is called the branches. So we have 7 branches and 6 loops like this. The current flowing in the loop, 2, 3, and between these two loops, and then within the outer loop, total of 6 loops. Okay, this is how we use the term here. Later on, we can analyze the circuit. We call them as node, branches, or loop. Okay, now we come to a very important part. I think this I think I talked about this before, right? I say that voltage node you should have 2 different voltage node between this device. So here and here should have a different voltage node. This is node 1, probably this is node 2, and here's a node 3. Okay, this is what it means. Okay, but sometimes we do have the three elements sharing the same nodes. We call this one as a common. In a physical circuit or in the practical world, we call this one as a common node. Common means they are sharing the same node. Okay, but here it didn't say it's a common, but I always view this one as a common node. So it looks like in this arrangement, in this configuration, they are called they call it as a parallel. Because since they are sharing the same node, the current can flow through it, at the same time. The same current can flow through this component, these three different components, the same current, because they are sharing the same node here and here. So we should have the same current flowing through. Another possible alternative is where is the series? There's a series. This parallel. Series is like this one, series. Series, we have element 1, and then element number 2, and element number 3. Looks like we have only one current flowing through these three elements. 1, 2, and 3. Only one current flowing through. But for this one, we have three possible current flowing through because they are sharing the same node. So the current all depends on the how much resistance it has for these elements. If you know the resistance here and you know the voltage, then you can calculate total current flow through the element. So this exercise wants you to identify which one is in series, which one is in parallel. You need this exercise really. So you see these two component here or elements, they are sharing the same node. Okay, so this because the same wire here, same node. So you treat this one as a one node. See, you can redraw them like this. Two node. One is like this. One is like this. You can always view these two as like this: 1 ohm and 2 ohm. So I say they are sharing the same nodes here. This node and this node. And this one, they are not sharing the same node, you see. 2 and 3, this 2 is coming from these two nodes and 3 is coming from these two nodes. So they are not sharing the same node. This one is a series. These two are considered series. These two is a parallel. Okay. So you need to identify which one is series, which one is a parallel. Is there any exercise which you need to do that? Let me see. Yeah, this is an exercise you can relate to that. This question relate to that as topics actually. You can first you have to see which one is the. But I think I made a mistake here. To solve this question, this is slightly more complicated than the previous one. And this question here, even though we know that these two are the series, they are not parallel, right? Wait, they are parallel. See, this thing and this thing here, they are sharing the same node, right? These two are parallel, but you have to be careful. They also sharing another branch with this 12K, so you cannot say they are all in parallel. So these two parallel is quite obvious, but these two are not parallel with this one. Okay, so if you cannot just go ahead and reduce these two into one, and these two there's no way for you to reduce it because this configuration is a bit outward. There's only way to solve this question here is to jump into the last topic here. To jump into the last topic where we have a very special arrangement right here. We have something we call the T, something we call the delta. Okay, we can convert from T to delta with this formula. For example, if you look at the dotted line here, the dotted line is denoted as a R1, R2, R3. The solid line is the R A, B, C. So this one said that you can convert the delta, you can convert the circuit from delta into, well, I call the Y, but they call the star. Oh yeah, this is a Y, sorry, Y. They call the Y. You can convert the delta to Y using the formula like this. For example, the original circuit with RA, RB, RC at the outer layer here. So on the inner one, we have R1. So the R1 is given by you from the R1, you look left and right, adjacent to R1, you get the RB, RC. So you put them on the numerator. And then on at the denominator, you just sum all of them together. RA, RB, RC, you sum all of them. Okay, and at the denominator, at the numerator, you just look at the adjacent one. Next to R1 is the RB, RC. So next to R2 would be RC and RA. And the denominator is the same. See? So this is the way how to memorize this one, how to memorize the formula. So when you come to the question like this, apparently this one is the, I don't know whether you can see or not, but to me this is the Y. This is the Y. Yeah. This tree is a Y. Even though it not looks like a Y, it looks like more like a T. But if you pull this one up, it looks like Y, right? So you can convert this one to delta. When you convert to delta, it will look like this. Okay. After you convert it, it will look like, here's a new one. Here's a new one. And this is a new one. And then you can forget about this tree inside here. And this one is parallel with this one. And this one is parallel with nothing. Okay. This one is parallel with this. This one parallel because they're sharing the same node. This not the same. So this not the same. So these two are parallel. Therefore, you can use the formula here to solve this question. This is a bit second level. I consider as a second level. But for the first level, is located right here actually, the series of resistance. For all the resistance in series, you can just add them up. Let me give you the quick example here. Let me give a quick example. I think the slide is not arranged in the proper sequence. Let me give you a good example here. I try to find the example. Looks like I need to draw it. Oh, here, yeah, okay, right here. For the resistance in the series, you can just add them up like straight away. Add them up. No, for example, you have a 1 ohm here, 3 ohm here. So the total ohm reduced to the voltage source remain the same. You reduce to only one resistance. So this resistance, we call the resistance total, is equal to R1 plus R2 only. It just you just add them up, and then you can find the total resistance here. But another circuit is a parallel. When we have a parallel circuit, voltage source and this resistance and this resistance, let's say it's a 2 ohm and a 5 ohm. Okay, how do I know it's a parallel? Because they are sharing the same node. This node and this node the same because there's no resistance here. This node and this node the same. Okay, so they are parallel. So when I parallel the R total, we can reduce these two into only one V and only one resistance. Okay, it's called the RT total. So the RT for the parallel circuit, we cannot just add them up like this. We need to use the reciprocal value. So this is called the reciprocal value, 1 over R1. Okay, so you R over RT, here is called REQ. I usually call it RT. It's a reciprocal of R1 plus the reciprocal of R2. So the quickest way for the two resistance is you take the product of R1 and R2, and then at the denominator you take the sum of R1 and R2. You can calculate the total resistance. So for this example, 2 times 5 over 5 plus 2. So the total resistance is 10 over 7 ohm. Okay, just like that. You can go through the conventional way, 1 over RT over 1 over or 1 over, but eventually you'll come to the same answer. Of course, we like to do the series. We can just add them up without any reciprocal value. We can just sum all the individual resistance, right? We sum all the individual resistance. We can find the total here. They call it REQ. Okay, but I don't think you have any question related to this. Not in this semester. In the previous semester, you have one circuit where you can you'll be asked to reduce the total resistance, to simplify the total resistance, but not here. I can't see any circuit. This one looks like one, but is partially. This one you still need the technique just I show you to convert from the delta to the T, to convert from to convert from the Y to the delta, the Y to delta. Okay, then you can after this you use the parallel and series formula to find the R total or R total, or the textbook like to use REQ, R equivalent, for the whole resistance here. Okay, there is no voltage source or current source. Okay, all the resistance, but for the circuit with combination of current and voltage source, with the current source and the for the current and the voltage source and the resistance, you cannot do that. You have to do it usually a different way, which we'll learn later on in the next session. After the lab, we'll learn the methods how to analyze a circuit like this or circuit like this. That one is what you have to learn in this class, and is to learn the techniques how to analyze the different type of circuit. It's a different type of the input devices. We have sometimes we have voltage source. Sometimes we have the this is a voltage source, right? Even though there's a current here, you can see the current here, but when you see the plus and minus is a voltage source. This one is obvious. Even though you see the volt here, but the arrows indicate is a current source. This is obvious. This is a voltage source. This is the current source. So this is a current source with a constant value, 2 milliampere. And this is a normal circuit, right? Normal circuit. Okay, we'll continue in your next session. So far, I think with the because we don't have time to go through every single slide here, it will already require more than two hours, I think, unless I speed it up. And actually there's very important information here. I hope you can really read yourself. No, after this topic, when you come to the Ohm's law, this is not Ohm's law. This is a wrong title actually. Where is the Ohm's law actually? Here is Ohm's law. Ohm's law. Like I say, if you can remember this one, I think it will come in handy in the future. V is equal to I times R. Okay, I is equal to V over R, like this. This is Ohm's law, really. This is a very important formula. But here, I don't think you can straight away answer this question also. For after today, you can go ahead and solve part A, part B. Part B just asks you to explain what is Ohm's law. See, the answer is all here already. Answer is somewhere here in between. You need to summarize it. What is the Ohm's law? Ohm's law states that the voltage across a resistor is directly proportional to the current. There's a definition. You see, this is the official definition. And of course, you need to provide the the function, the equation used by the Ohm's law. Okay, and for the part 2, you need to find the I1 from this circuit, and this one we have to learn it in the next lesson. Okay, how to find I1 from here using some theorem, some circuit theorem, or the some techniques or methods. We can actually find the I1, this unknown I1 here flowing in through the 12K resistance here. Okay, but this is what we can do today. This so far we can do. But before we go, I really want to emphasize one thing, that you really need to understand clearly about these two laws. Another, beside the Ohm's law, there are two more which are very important for the unit 1. There's a KCL and KVL, Kirchhoff's voltage law and current's law. Let me take about 1 minute to go through this. Okay, for the current's law, if you look at the different current coming in or going out from this node, the KCL stated that the sum of all the currents is equal to 0. For example, you have this going out, for example, 1M going out, 4M going in, let's say 2M going in, 3M going in, let's say another 0.5M. No, let's use a integer better. Let's use integer, not to confuse you. Let's say another 4M going in, and this coming out, let's say coming out is another 2M. So what is the I1? So you can use a formula like I1 plus everything is equal to 0. Okay, so I1, you take I1 over there, that means what? I1 plus everything else must be equal to 0. Okay, I1 plus everything else to 0. So I1 equal to minus I1. You take this one over, become minus, right? So you just sum all this value, like the 1A plus wait, hold on, not so easy. Okay, not so easy. The one going in, let's say the one going in is a positive. Okay, the one going out must be negative. There must be a different direction, right? So the one going in is a positive, one going out is a negative. Okay, let's put them in here in the equation. 1M is a negative. Another going out is a minus 2M. And then the one in is a plus 2A plus 4. So minus 1 equal to minus 3 plus 6. So this one equal to 3M minus 1. So take the minus over. I1 equal to minus 3A. Hey, wait a minute. I1 is going in. Something I made a mistake here. Wait a minute, let me see. probably I shouldn't take the I1 over there. But when I take I1 over there, it become negative, right? Let me see. This is going out. Going out, let's say is a minus. Going out also minus. Here is going in, going in. 2 and 4 going in. So, I think I didn't make a mistake here. Positive, negative. I want to do negative. So I want. Oh, I think this is just a. Sorry, this is a. I don't really need to match this arrow because this is without any value. Now I just simply put the value here. So doesn't mean that I want in this direction. So the I want the final answer I come out is a negative for sure. Is a negative value. So means that this I1 is not pointing up, it should be pointing this way. You see? This is what I mean sometimes when you have the experience. For example, you analyze the circuit. Let me pick one circuit. Like for example, initially you think that the current for example, let me pick a better circuit. You see that the current should be flowing down, right? Because here is the ground is the lowest already. The current should be flowing from the top, from the highest point to the lowest point. So for example, let's say you assume the current here. Let's say you assume the current here is going this way, opposite. When you go through the analysis, you'll find your answer to be negative something. It means that your current, what you assume is the opposite direction. So the current you assume going up, so instead going down. So from the answer, sometimes we can tell that the direction we assume initially is a totally opposite. For example, here you can see sometimes we come up with a negative answer. For this one is all positive answer. Sometimes when we come up with the negative answer, it just simply means that the one we assume is totally opposite. Sometimes we do have the negative answer, which we will encounter later on, not on this unit. This unit only the basic. Okay. In the subsequent unit 2, you definitely will see the answer with the negative answer, negative I. When you get a negative I as your answer, for example, negative I, negative 1 ampere, it simply means that the I3 is going the other direction. The I3 is going this way. Okay, if the answer is negative. Now it's a positive, of course, right? I mean, if the answer is negative, that means that the current you assume initially should be positive, should be the other direction. This is what happened when I try to put in any value here. I put in any instant value here. Try to demonstrate to you how to apply this law. I come up with a negative, right? So simply means that the current should be going that direction. Okay. Sometimes when you the direction of current when you assume doesn't mean it is always matching the one you're matching your assumption. Sometimes the current may go the other direction. After you take all into account, you take all the current going to the same node into account, and then eventually you'll find that whether your assumption is correct or not, whether the current is going in or going out. Okay, but here is just a simple figure to explain this law. You know, just now when I get the negative, it doesn't match the arrow. I quite panic because I just put any value here. Remember, this could be probably 1 ampere. This could be 5 ampere, right? I just simply put any value without thinking. Of course, we can come up with every time you assume a different value, you can assume a different answer, right? You'll get a different answer. This is for sure. All right, guys. I think we study over time. I will try to go a bit faster next time. Okay, to cover where we left off this round. I think we still need to go through the KVL, KCL because they are quite important for you. we shouldn't skip this few topic. But we try to here's a good example for you to learn how to simplify the circuit. To simplify the circuit like this and to reduce it into only one component. Only one component here. The last component is a I call it RT, right? R total is 9 ohm. You can try to practice this circuit yourself. Whether see you can come up with a 9 ohm or not, the total resistance in the circuit using the parallel and the series methods. All right, guys. I think there's I don't want to talk too much already. It's over the time. So I want to ask you guys any question you want to ask or not before we go. Oh yeah, sorry, I forgot to read your message. Who is that? Pavana? Pavana, are you still there? Any question you want to ask?
Yes, sir.
Yes. Any question you want to ask?
Actually, I wanna ask. The just now you showed the I negative I. Can I see the question, please?
You mean the assignment question? Which question
Uh,
do you refer to? The actual assignment?
no, the
The slide.
yeah, slide.
Which one? You mean the negative one? The negative answer?
The just now you show the negative I equals to uh,
This one, right?
uh no.
Here?
Yeah, yes. So
No.
may I?
Yeah. Yes. What's your question?
Okay, can I know how come the high become negative? Because the arrow show go inside. So in the arrow go
Oh yeah,
inside
yeah. Because
negative, right?
just now I was trying to explain that because I just simply put all this value in, so this one is not reliable anymore. See, you understand or not?
Oh,
This figure is here to explain this law without any value. But I just want to demonstrate how this work. I simply put any value here. You can see
oh,
if I put a different value, let's say I put the 1n here, the answer will probably come to positive already, right?
oh,
So
okay.
don't take it seriously about all this. I just simply throw in all the values here. It doesn't mean this is the actual circuit.
Okay, got it, sir.
Another word I try to explain to you is that even though in the beginning you assume the current is going this direction, but at the end you get the negative value, that means what you assume is opposite. You get what I mean or not? Uh,
Uh,
you get what I
no,
mean? Okay, let me give another example.
okay,
And probably I will help you understand it. Let's say at a certain month you make so much money a certain month, and then you for example you assume at this month you don't know which month, you assume that you make certain money, so it's a positive, but you are sure that at another month you're losing certain money, you're losing, let's say you're losing 10K, but another month you make another uh hold on, you make another uh 8K. So the total you make should be sum of all the money here, right? The total you make for these 3 months should be 8K. Wait a minute. By doing this is also wrong, right? Also wrong. So you don't know how much you make here. You don't know how much you make. So the total you make is X plus 10K. Sorry, X minus 10K. Minus 10K is the one you lost, right? Minus 10K you want to lost. And then plus 8K. So looks like X is equal to loss 2K. But initially you assume it's a positive is wrong. Initially you assume positive is wrong. After you done all the calculation, this month you lost, this month you make, this month you assume you make, but you calculate the value, X is equal to minus 2K. This is what I mean. initially you may make the assumption of positive, but eventually the answer is negative. Means that month you lost money. You get what I mean, or not? What I mean is, later on in certain circuit, you can assume the current in this direction, but when you come up the answer to be negative, you simply indicate that the assumption is wrong. It's actually going the other direction. That's it only. You don't have to too worry about the sign, the positive and negative sign. It just simply means that which direction the way the thing goes, you see. So for example, you have minus 3 watt. It simply means you're losing 3 watt, you see. But initially, probably you assume that you can generate 3 watt. But after calculation, you come up to the negative value. It simply means that you are dissipating a 3 watt, not generating 3 watt. Okay, but we'll see more example related to this issue here. Okay, in the next lesson. Not to worry right now, see. Okay, we have the message from the how do I pronounce your name? Jufaris, right? Jufaris. Of course, we can set up the WhatsApp. Okay, this is what I'm going to do, guys. You see, I'm going to post the WhatsApp group link. I'm going to create a group link and share it on this discussion forum. So you can go there and simply click on the link and then join our group. I'll be posting the link here. Where is it? Where is the EFX? I'll posting the link here later on after the class. Where is it? At the discussion section. I'll posting the link here, and for you guys to join the group. Okay, but you give me some time for me to create the group, a new group. Then I posting the link here. Okay, then you can come here and click on the link to join our group. Is that okay, guys? Does this sound good to you?
Okay, sir.
Yeah, I think that's all right. Any more question? Any more question? Otherwise, we have to end this session right now. And our next time we wait, another question here. I think when you download should be PDF file, right? When you download it, you should get a PDF file. I'm quite sure it's a PDF file. Why you come up with the HTML probably is your PC setup settings set differently. You see, when I click on the course content here, when I click on this download icon, I guess a positive. I guess a PDF file, not positive. PDF file. Okay, it's a PDF file actually. You see, it's a PDF file. It's a zip file actually. It's a zip file. Okay, but this is the introduction. It's not a topic. I think we shouldn't have any issue with the downloading of this content. Okay, guys. I think that's all. Any further question? If not, the next time we meet should be on the 18th, where we're going to go through the lab, 10 hours lab session. Okay, I'm going to share this file also on the discussion forum, so you can pick this file up there. All right, guys, that's all. I don't want to take too much time from you anymore. All right, see you next week. All right, goodbye.
Thank you, sir. Bye.
Thank you. Bye.
Thank you, sir.
Let me stop recording.